Hello, welcome to the second part of this screencast on building a fast DI container using TDD. We'll first do a quick recap of what we achieved on the previous one. We basically had a pretty basic container, which was basically a dictionary that maps service types to their corresponding factory objects, which are functions that basically initialize the objects. Registration was simply a matter of passing in delegates that perform the construction of the objects, and resolving is just calling the resolve with the type of the service we want to resolve. What we're going to add in this episode is the ability to pass constructor arguments to the object being resolved. This is a very relevant scenario because typically when you have, let's say, a repository class, you want to pass some configuration to the object as you are constructing it. For example, the connection string. And the proper way to do that is passing it to the resolve rather than trying to inject that as if it were a regular dependency. So the first thing we'll do is extend a little bit on our example for the bar class. We are going to add a couple new properties and also the relevant constructors that will receive values for those properties, and we'll keep the parameterless constructor so that we don't break existing tests. There we assign the local values to the properties and so on. Okay, so now let's go for the test, and the test should make sure that the constructor arguments are passed from the resolve invocation. So we're going to create our container as we did before. Register the new bar, and let's see how we work out the API for this. What we had before was a way to pass the delegate receiving a container argument and passing in the delegate to construct the bar. Now we need to receive an additional argument there so that we can pass it on to the object constructor. So what we can do is add another argument that is received by the function, and so in addition to the container we receive another one, which is a string, and we tell the register method that we are going to register an iBar, but we also need to receive a string to pass it over. On the resolve we're going to do the same, basically specifying that we are resolving an iBar, but additionally passing a string, and we can make an assertion that that actually indeed happened. Yeah, we need to cast that as a bar so that we can get access to the property and make the proper assertion. So let's go and work on these overloads on the container. For the register, it's going to be pretty much the same as the one we had. We just need to add a new targ to the function, and that will be pretty much it. That compiles. Now we can move on to the resolve part. And for the resolve, it's going to be also very similar. We are reusing the add method to the factory. The key is still the service, and for the resolve then we're going to just also change the signature of the method by adding the targ and casting it to the proper type. Now at the invocation of the factory we pass the argument that we will be receiving in the resolve. So now that compiles, and let's run the test, and let's see if that works. It's taking a bit longer than usual, but it should get there. There we go. Compile, build, run, pass. So we indeed got the argument there. So another supported scenario that we should have is, of course, be able to register, as we did before, the class without arguments and the new one with arguments. We should support that. So let's do that and see what happens, because if you were paying attention, you probably noticed that we are registering using the service type as the key to the dictionary. So we are not taking into account the arguments that we are passing to the function. So in this case, I would say there will be an error. Let's make an assertion that we are getting a non-null for both bar 1 and bar 2 and see what happens. Okay, we need to rename the method, of course, test, which should be something like yeah, can resolve with multiple constructor overloads or something like that. And let's run again and see what happens. Oh, we got the exception, and the exception tells us that an item with a given key has already been added, meaning that the dictionary of the services we had when we tried to register the second one with the constructor overload, it actually fails because there's already an entry with that key. So we'll need to make a differentiation. We'll need to differentiate the registrations not only by service type but also by the factory type. So we'll need a new class. We will call it ServiceKey, and this can be a class that will receive basically two pieces of information. It doesn't need to be public. It will receive the service type and also the factory type. We can make two read-only properties, prop G, that's the shortcut for the code snippet to get a public getter private setter property. One is the service type, the other one is the factory type, and we just assign those two properties from the constructor. Good. Finally, because this is going to be used in a dictionary, we will need to implement the equals and get hash code. So I have a code snippet which is unfolded, follows the .NET Framework Design Guidelines. So all I need to do is compare the first object service type with the second one service type, and the same for the factory type. Can get rid of that line. And getting the hash code is also pretty typical, combining basically the hash code of the service type with the one for the factory type, and returning the hash. We'll need to add a unit test for this key class just to make sure that it works as expected. The service key is internal, but I have already set up the internals visible to this project so that I can instantiate the service key from here. No, that test, no, the DS test. Yep, that's the right one. So now let's say that the key should equal by service and factory type. We'll create two keys and make the appropriate assertions. We don't really care much about which are the types that we are passing in, because our service key doesn't care either. So we assert that they are equal. We also should check that the hash codes are equal. And next we need to add a test for the non-equals. So let's say we change the service type on 1, so key to not equal if they have different service types. And we can put anything there, object. Now we need to change to non-equals, not equal. And we will do the same for the factory type. Let's run this, see if it works. Yep, it works. Okay, so we got our key. Now we go here, and on the container we'll basically change the places where we're using the service type, and basically now use the service key. For the register, we will just go ahead and create the key first, and then use that to add the factory to the dictionary. That would be a key for the type of the service and the type of the function. Replace the add with the key. Let's do the same with the other overload. We're going to add with the key, and then we have to add targ. For the result, it's going to be very similar. We just make up the key, then retrieve the value, and do the same for the other result. This time passing the targ. So we can go back to the test, run, pass. Excellent. So we have support for constructor arguments and registering multiple overloads simultaneously without having them collide. Now let's go on and add another test case for the example with 2 constructor arguments, and this will serve the purpose of showcasing some code duplication that we have at this point in our implementation. So let's add the one that receives a boolean, construct the boolean, passes the boolean to the constructor and also to the resolve, and let's add an assertion for that. And we will start by just going back and basically copying and pasting to add a new overload. And this is relevant because this exercise to showcase the code duplication will also come in handy by the time we need to add the 4, 5, or 6 overloads for all the number of arguments that we want to support. So we'll start by adding targs here and there on the register. We also need to do the same on the resolve. For the register, the code continues to be the same, adding the factory to the dictionary, and for the resolve we'll need to add also the other overload with the new arg. And let's see how this duplication can be fixed later on. So we have the tr2 there, tr2 over there too. Exit the cast, and finally pass argument 1 and argument 2. Go back to the test. We should pass with no problem. We just copied and pasted the implementation from the other ones. No reason to fail. Now let's go and take a look at the code that we are building here. The register methods are all very similar. The only variability is the type of the function, of the factory function. So we'll create a new register implementation private method, which will basically receive the type of the service and the type of the function as generic arguments. And after that we can pass the strong typed factory into the method, and now this method can basically do the generic algorithm there, which is building up the key. Not so much of an argument, but algorithm, but to avoid repetition, it's always good. So the key will be the type of the service and the type of the Funq that is being received. Now we can simply replace all the existing register methods which basically call register implementation with the T service. In the first case, it's gonna be the func of the container and the T service, and we pass in the factory. Same goes to the other two guys. One case passing the TR, the other case TR1, TR2, and you can see how this is going to be applied to the R3, 4, 5, and so on. And we can move that implementation to the bottom so that we can keep all the behavior, the actual implementations at the bottom, and the usability overloads at the top. Now for the they're all one-liners now, so that's good. Now let's work out through the resolve ones. And the resolve ones is also very similar, has a common structure, creating the key, retrieving the factory, and invoking. The invoking is the key part, because that needs access to the context of the caller, in this case the resolve, so that it can pass the arguments back. So we'll see what we can pass around so that we can do that invocation with the arguments received by the caller. So the resolve implementation will also receive the service type and the type of the function. We still don't know what we'll pass in as an argument, so let's leave that empty, and let's take the generic code. So we look up the key. Now the type of the service will be the type of the service and the type of the func, and the factory will retrieve it from the dictionary, and we can already cast it to the type of the func. We know it is. And now it comes the part when we need to invoke that and get an instance of the service somehow. And finally we need to return that instance. Now invoking so we have access to the factory, strong typed, but we don't have the arguments here. So in order to pass in the arguments, we are gonna pass the factory to the caller, which is the one responsible for passing in the arguments. So what we're gonna receive as an argument in this method is a function that can accept the factory method and return as a service. Okay, so this is the invoker for the factory. So how do we get an instance? We call the invoker and we pass the factory method, and basically the caller, when it receives the factory, it will invoke the factory, passing the arguments that it has in its own context. Seems a little bit convoluted, but it's gonna come in very handy when we have to start doing lifetime management of that instance that we are getting back. So basically we will call resolve implementation of the T service. The func is gonna be the exact same func we were using before, tr1, 2, and what we receive, the callback, is the factory. So we can pass in the arguments. So we'll call that factory, and we can now invoke the factory and pass ourselves and then the two arguments. Beautiful. And we have to do a return there, of course, because we need to return the instance. Now we can copy that over, and same thing but with one less argument. Same thing there. Yep, there we go. So it looks a little bit weird, but let's step through it so that you can see how it works. Run it on the debugger. So we first go to the register method. That's where we just add the factory to the dictionary. The factory is typed to the arguments that we said that we're going to pass in on resolve. And here we are in the resolve method. We do have the context for the arguments. We are passing into the resolve implementation, which goes, builds up the key, retrieves the factory, and now our resolve method gets called back with the factory. At that point is where we can call the factory and basically pass in the arguments that we got in the resolve. That gets, of course, into our register lambda, so we get the arguments passed to the var constructor, we return the instance, and all the tests, all the assertions pass because we're good. Okay, so what we achieved so far is still a very streamlined and simple implementation, which is under 10 lines of actual behavior code. And on the next episode, we're gonna work on the Fluent interface so that we can add named services, start working on the ownership of the instances, and so on. So stay tuned and see you on the next one.